Okay, so what if I told you there's a cleaning method that's powerful enough to strip gunk off industrial machinery, but so delicate it can clean priceless historical artifacts? And here's the kicker. The cleaning material itself, it just vanishes into thin air the second it does its job. Sounds like something out of a sci-fi movie, right? Well, it's not. It's the very real science of dry ice blasting, and we are going to break down exactly how this magic works. You know, when we think about heavy-duty cleaning, our minds usually go to things like sandblasting, pressure washing, we're using some pretty harsh chemicals. And they all have one huge problem in common. They leave behind a massive mess. You have contaminated water, sand, chemical sludge. You're basically creating a whole second cleanup job. But what if you could just skip that part entirely? What if the cleaning agent just disappeared?
And when you put the old ways side by side with dry ice blasting, the difference is it's night and day. On one side, you've got abrasive methods that can damage surfaces, nasty chemicals, all this secondary waste, and you usually have to shut down production, which costs a ton of money. Dry ice blasting just flips that whole script. It's totally non-abrasive, there are zero chemicals, it leaves absolutely no residue, and get this, it can clean machines while they're still hot and running. This really is a total shift in how we approach cleaning.
So let's dive into it. We're calling this the vanishing blast. It's a truly revolutionary method that gives us this incredibly elegant solution to a really messy, age-old problem.
At its core, the idea is actually pretty straightforward. You take these little pellets of solid carbon dioxide, yep, regular old dry ice, and you use a blast of compressed air to shoot them at a surface. But here's where the magic happens. The second those pellets hit the contaminant, they instantly go from a solid to a gas. They just sublimate, and poof, they're gone. The only thing left is the original grime, which you can just sweep or vacuum up.
And that little vanishing act is what unlocks all these incredible benefits. First off, because the pellets are pretty soft and disappear on impact, the whole process is non-abrasive. It won't etch or damage the surface underneath. It's also non-conductive, which is huge, because it means you can safely clean live electronics without shorting them out. And since it's literally just frozen carbon dioxide, it's non-toxic, it's food grade, and it's even got the seal of approval from the EPA, the FDA, and the USDA.
Okay, so that all sounds amazing, but how in the world does a little frozen pellet of CO2 actually remove tough stuff like grease, paint, or baked-on gunk? Well, this is where we get into the really cool science behind the magic. It's a fascinating three-punch combo.
So it all happens in a split second. First, you have the kinetic impact. The pellets hit the top layer of grime and create tiny fractures. Second, you get a massive thermal shock. That intense cold, we're talking minus 109 degrees Fahrenheit, makes the contaminant super brittle and causes it to shrink, which breaks its bond with the surface. But here's the real knockout punch: sublimation. The pellet instantly turns from a solid to a gas, expanding almost 800 times its original size. This rapid expansion creates a series of tiny shock waves that literally lift the grime right off the surface from underneath. It's brilliant.
So now you've got this cleaning method that's both incredibly powerful and surprisingly gentle. The big question is, what can you use it on? And the answer, you'll see, is, well, pretty much everything. The range of applications is just wild. In the world of heavy industry, this is a total game changer. For aerospace, it can clean super sensitive turbine blades without leaving a single scratch. In car factories, they use it to clean welding robots while they're still hot, which practically eliminates downtime. For foundries and power plants, it means they can keep all that critical, expensive equipment online and running at peak performance. But here's what's so amazing: the sheer versatility. The exact same technology they use on giant industrial turbines is gentle enough for historic restoration projects, cleaning priceless statues without causing any damage. Since there's no water, it's perfect for sanitizing equipment in food processing plants, and its non-conductive properties mean you can safely clean delicate circuit boards. Oh, and for disaster cleanup, it removes toxic mold and soot without adding any moisture, which, as you can imagine, is absolutely critical. Now, whenever you have a technology this effective and this versatile, you'd expect a pretty big business opportunity to pop up around it. And yeah, you'd be absolutely right. Let's take a quick look at the numbers. Free, $0.5 billion. That's the projected size of the global market for dry ice blasting by the year 2034. That number right there is a huge signal that this technology is moving way beyond some niche solution and becoming a mainstream industrial powerhouse. And this chart really tells the story. You can see the market is set to more than double in just over a decade. Jumping from $1.4 billion back in 2023, that's a compound annual growth rate of almost 9%.
So this isn't some slow and steady trend. We're talking about an industry in the middle of a major expansion.
So why the sudden boom? Well, it's really a perfect storm of 4 major factors all hitting at once. Number 1, there's this massive global push for eco-friendly and sustainable solutions. 2, industries are under constant pressure to cut down on expensive production downtime. 3, there's a much bigger focus on worker safety, which means getting rid of hazardous chemicals. And finally, the technology itself just keeps getting better and more efficient.
So, the future is looking really bright, but it's not a totally clear path. There are still some challenges to deal with. So let's wrap this up by looking at the biggest opportunity and the biggest hurdle this technology is facing.
The biggest opportunity, without a doubt, is that this technology just perfectly aligns with where the world is heading. As environmental regulations get tighter and companies get more serious about their green initiatives, a cleaning method that actually uses reclaimed CO2 and produces zero secondary waste, that's not just a nice-to-have anymore. It's becoming a necessity. It's the high-performance cleaning solution for a green-conscious world.
But there are hurdles. The number one challenge is the high upfront cost of the equipment. That can be a real barrier to entry for smaller companies. And then you have the logistics. You need a steady, reliable supply of dry ice, and you can't just stockpile it for months. It sublimes away. So cracking those economic and supply chain issues is really the key to unlocking even wider adoption.
So let's just step back for a second. We're talking about a technology that cleans with frozen gas and leaves literally nothing behind. It's already being used on everything from jet engines to priceless works of art, which really just leaves us with one final and I think fascinating question. As this technology gets cheaper and more accessible, what will we clean next with vanishing ice?